And today we are going to start an important topic, that is covalent bonding. As you know very well that in the previous lectures we have done ionic bonding, covalent bonding, metallic bonding, and our today's topic is dative covalent bonding. That is also known as coordinate covalent bonding. Okay. So first of all, what is the definition of covalent bonding? In dative covalent bonding, shared pair of electrons is donated by only one atom. Okay, this is the important thing. As we studied in the ionic bonding that electrons are transferred from one atom to the other atom. Okay, in covalent bonding, pair of electrons shared from both the atoms. One atom from the one atom and the second electron from the another atom. Okay, but in dative covalent bonding, both the electrons are shared from one atom. Okay, now donor means the atom which gives. Okay, the donor means the atom which donates its electrons, that is known as donor, and acceptor means the atom which take those electrons are known as acceptor. Okay, now what are the characteristics of donor? How can we distinguish that it's a donor and it's an acceptor? So first of all, the donor has a complete valence shell. The donor has a complete valence shell. And number two, one or more lone pairs should be present. Lone pairs mean the electrons which do not take part in chemical bonding. Okay, we have already discussed this, what are lone pairs, what are bonding pairs. Okay, now characteristics of acceptor: it should have incomplete valence shell. Okay, one or more lone pairs should be needed to complete its valence shell. Okay, for example, apply these concepts on this example. Fluorine is F9, means it has 7 electrons in its last shell, means F have like this, just a minute, this. So it has one pair, two pair, and three pair. Now, how can we know that it should be a donor or an acceptor? Now, the donor means it should have complete valence shell. So as you can see that it do not have a complete shell. That's why it can't be a donor. Okay. Now moving towards acceptor. Can it be an acceptor? Now let's see. Incomplete valence shell. Okay. This criteria is fulfilling, but this one, number two, one or more lone pairs should be needed. One or more lone pairs should be needed. In one pair, you know that in one pair there are two electrons, but it needs only one electron to complete its valence shell. That's why it can't be an acceptor. Okay, moving towards hydrogen. As you know that hydrogen has one electron, but it has donated already its one electron. Now it has zero electrons, so it needs one pair means two electrons to complete its valence. Okay, so it can act as acceptor because it needs two electrons. Okay, means one pair of electrons. I hope it's clear to you. Now here I'm going to give you some tips which will help you a lot. Okay, tip number 1, group 2 and 3 compounds. I'm talking about compounds, not the atoms. Okay, I'm talking about compounds, not the elements or atoms. So, group 2 and 3 compound can form dative covalent bond. Okay, and they will behave as acceptors. Okay, they will behave as acceptors, means they will accept the lone pairs. Okay, another big tip, that is group 5, 6, 7 compound can form dative covalent bond and they will behave as donors, mean they will donate their pairs of electrons. Okay, for example, formation of ammonium ion. Formation of ammonium ion. Now you should have to know what is the formula of ammonium. H4 positive. Okay, now if the examiner asked us to make the stick diagram, to make the dot and cross diagram, now then we should have to break it into like this: ammonia NH3 plus H positive. It will be like this, okay? Because NH3 is okay, and the one H which has positive one, we will write it separately, okay? Now if we will make the stick diagram or the structural diagram, it would be like this: N here H, and as you know that nitrogen is in group 5, that's why it has 5 electrons in its valence shell. 3 are already bonded and 2 are left, means one pair is already here, okay? These 2 electrons will be shared with hydrogen. Now apply this tip over here. We asked that group 5, 6 and 7 compound can form dative covalent bond, and they will behave as donors. Here you can see nitrogen is in group 5 and it has 2 pairs and it is sharing it with hydrogen, means it has a lone pair, so it means it is a donor. Nitrogen is a donor because it is sharing 2 electrons, okay? This is structural diagram. If the examiner asked us to make the dot and cross diagram of the ammonium ion, so it would be like this. N over here, okay? As you know, hydrogen, 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 okay? Okay, now as you know that here we have hydrogen, 1 electron from hydrogen and 1 electron from nitrogen, okay? Here we have hydrogen, hydrogen and hydrogen, okay? Here we have 1 electron from hydrogen and the other from nitrogen, and here we have 1 electron from nitrogen and 1 from hydrogen, okay? These are the 6 electrons, but 2 it has a lone pair that would be shared with the hydrogen. That's why we will show it with same, because these 2 electrons are from nitrogen, and if the both electrons are from nitrogen, then they will have same representation, okay? This is the dot and cross diagram for what? For ammonium ion. And one most important thing, we have to place an arrow when we show this from donor to acceptor, like this, means these electrons are sharing by this to this. So we have to place an arrow in structural diagram, not in this one, but in this one, okay? So I hope it's clear to all of you, and if you have any queries, comment and I'll respond to you as soon as possible. So thanks for watching.